All right, let's look at naming carboxylic acids. So carboxylic acids, like every group on this list, are a priority group, and they have a special parent chain suffix, in this case oic acid for carboxylic acids. So we'll count the carbons and have a pentanoic acid versus a pentanol for an alcohol and so forth. And if you look at our chart here, carboxylic acids being the highest, and then anything lower on the chart gets a subordinate group, or any carboxylic acid we can't get into a parent chain with multiple carboxylic acids will be a subordinate group and be named carboxy. But each other group has its own name and has a video associated with it to discuss naming for those functional groups. But let's look at carboxylic acids. Keep it simple here. We are going to go through our normal process of circling the parent chain, writing the names of the subordinate groups, numbering the chain, and then assembling the name with stereochemistry. Notice at the end of the chart here, our alkenes and alkynes, they don't have a subordinate group name because they're always built into the parent chain whenever possible, unless we can't get them all into the parent chain. And again, other video discusses naming alkenes and alkynes. So let's look at these examples. So when the carboxylic acid is the highest priority group, let's name these. So we know for a fact carboxylic acids being highest overall, the carbon of the carbonyl counts. So we're going to have carbon 1 in each of these, and then we're going to take the longest carbon chain containing the highest priority group. Carboxylic acid. 1, 2, 3, 4, and 5. The hydroxy group, alcohol is a priority group, but in the presence of a carboxylic acid, it loses its priority, becomes a hydroxy group. And then a methyl group here, 1 carbon methyl, there CH3. Okay, and so stereochemistry wise, carbon to 2 oxygens would be higher in priority than carbon to 1, higher in priority to a methyl. Hydrogens back, that's an S here. And then in the 3 position, we have an R. Okay, so putting the name together for the carboxylic acid, 5 carbons. But first, we need our stereochemistry. So we have a 2S, 3R, methyl and hydroxy. Hydroxy is before methyl alphabetically, so it comes first. 3 hydroxy, and then a 2 methyl. How many carbons? 5 overall. Pentanoic, separate word, acid. Okay, so 2S3R, 3 hydroxy, 2 methyl, pentanoic acid. Look at another example here. So we need to get our carboxylic acid and our alkene into the parent chain. So if you look at our video on tiebreakers for priority groups, the first rules are to get the highest priority group in and then as many alkenes, alkynes as possible. If there's still a tie, then we would go to the longest overall chain. And that's the pre-2013 naming rules. So if we look at 1, 2, 3, 4 here in carbon 2, we have a 1, 2, 3 butyl, or propyl group, excuse me. Propyl group. And so we would name this a subordinate group of propyl, 2 propyl. No stereochemistry on the double bond because we've got 2 hydrogens on carbon 4 and no chirality indicated at carbon 2, even though it is a chiral center. A 2 propyl, but 3-ene oic acid. So 2 propyl, but 3-ene oic acid, or we could have also said 2 propyl, 3-butenoic acid. All right, so putting that name together. Now, for our next scenario here, we might have more than 1 carboxylic acid present. In this case, we can put a 1 on either, but we need to lower the cyano group that is subordinate. It's a nitrile, but it's lower in priority than a carboxylic acid. So our parent chain here will contain both of the highest priority groups, but we can also lower the cyano group by numbering left to right there. Now carbon to nitrogen is lower than carbon to oxygen, so we'd have a 1, a 2, and a 3. That's an R. Clockwise rotation there gives us an R chiral center indicated at position 2. We don't need a number because there's only one chiral center, so we'll just call that an R here. And that's an R2 cyano. And now we have 5 carbons, so pentane with an E to separate N and D here, dioic acid. So 2-cyanopentane dioic acid. That's how we name carboxylic acids with more than one carboxylic acid, one at the end of each chain, as a dioic acid with the number of carbons in the parent chain written out with the E. Okay, well, what if we have more than 2 and we can't get all of our carboxylic acids in the parent chain? So there's a couple ways to handle this. Let's first look at the longest carbon chain here containing 2. We could have started up at the top, so these are the same thing. I just drew one as condensed, one as fully expanded there. And we can call this a carboxy group. And so with a 1, 2, 3, 4, and 5, no chirality shown, we would have a 2-carboxy pentane dioic acid. Okay, and that is again the old way of naming these tricarboxylic acids and above. However, if we were to use the newer rules, okay, we would separate all of these off from a chain here of 3 carbons, 1, 2, and 3, and we would call this a propane 1,1,3 tricarboxylic acid. And this is the updated way of naming these compounds. So whichever way you prefer is fine by me for my class, but you need to make sure that you're using the correct set of rules elsewhere.